Hello, this is a video to show how to solve three trig equations, starting with this one here. Now the way I'd solve this first of all is to change the range from 0 to 360. I would add 30 to both because this is the range for theta up here, but we need the range for theta plus 30. So when we're doing the cast diagram later on, we need to go between 30 and 390. So just added 30 to both sides of the range here. The next thing I do is probably remember that cosec, the third letter of cosec is S. So that means cosec is 1 over sine. So I change cosec to 1 over sine, and then I've still got in this bracket theta plus 30, and it still equals 5. Next divide by 3, so then 1 over sine theta plus 30 equals 5 over 3. Now if we do the reciprocal of both sides, we get this, and this is very similar to the kind of questions you would have done in year 1. So now we just do inverse sine of both sides. You need to make sure your calculator's in degrees for this, and I think you should get 36.9 degrees. That's your principal value that you get on your calculator. And whatever you do now, don't subtract 30. We'll do that at the very end. Okay, so before you subtract 30, you need to use the cast diagram to find all your other values. Okay, if you prefer to use a different method to the cast diagram, that's fine. If you like general solutions, use those. But I've always used the cast diagram. So this is what I would do. 36.9, so this is 0, 90, 180, 270, and that's 0 or 360. It's 36.9, start at 0 and go up. So I'll put that there. Now you can see in this question that sine equals plus 3/5 here. So that means that sine must be positive. Sine is positive here. All the functions are positive in that quadrant, but also sine is positive here and nowhere else. So that means we need another line over here. So we reflect our original line in the vertical, and we've got 36.9 over here. So now our line is in the our lines are in the two quadrants where sine is positive. Next, start 0 and go round. Every time you hit a line, that will be a solution. So we've already got that one over here, 36.9. Let's start again and go round. So that solution there will be 180 minus 36.9, which would be 143.1. So 143.1 degrees. And if we carried on going around again, that would be 396.9. But as you can see, that's outside our range, so we wouldn't want that. Also, we don't want any negative values. If we did want negative values, we'd go backwards and we'd have a value there of minus 216.9. But we don't want any negative values because our lower bound for our range is plus 30. All right, so we're nearly finished now. Remember, these values are for theta plus 30 degrees. So we just need to subtract 30 from both of these. So minus 30 will give us 6.9 degrees, and minus 30 from that will give us 113.1 degrees. So that's the answer to that. Two solutions to that equation. Let's have a look at the next one. So this one, again, probably a good idea to start looking at the range. We've got a 3 theta and a 3 theta here. So I'll probably just change the range from 0 to pi. I want the range for 3 theta, so I'm going to do 0 times 3 is 0, and I'm going to do pi times 3 is 3 pi. Okay, so we'll need that later on when we're doing the cast diagram. All right, the next thing I'll probably do is remember that we need to get either all sines or all coses or all tans before we can solve an equation like this. So remember that tan theta equals sine theta over cos theta. So if we divide both sides by cos 3 theta here, we'll get 5 sine 3 theta over cos 3 theta equals 2. And so this is going to be tan 3 theta. And let's divide both sides by 5. So we get 2/5 there. Now we could do inverse tan. So that would be tan to minus 1, 2/5. Now this time be careful because of this pi up here. You need to make sure we're in radians. Okay, so make sure your calculator is in radians. And if you do it inverse tan or shift tan of 2/5 on your calculator, I got 0.381 for this. Actually, I'm just going to move that across a bit because we'll get a few more values in a minute. So 0.381 is the value I got on my calculator. Keep it to a few decimal places because we're going to have to divide by 3. Not now, but the very end we'll divide by 3. Now you could use the cast diagram here. You could use general solutions, but when it's tan, I just remember that tan repeats every 180 degrees, or in this case every pi radians. So I would just keep adding pi until we go outside our range. Remember our range is this. Okay, so if we add pi radians to this, we'll get another value here of 3.522. So we're just adding pi. Let's add another pi. So just keep doing that, keep adding pi. This would be 6.6663, and if we add another pi, that would be 9.805, but that will be outside the range. If you do 3 times pi on your calculator, you'll see that that is greater than 3 pi, so we can cross that out. We don't actually want that one. You can see we don't want any negative values either, otherwise we would subtract pi's if we did want negative values, but we don't. Okay, so nearly finished now. We've got all our values in our range that we need. So to finish off, we're just going to divide everything by 3 now. So divide by 3 all of these values, and I got 0.127, 1.174, and 2.21. These are all in radians. Okay, so I think those are the 3 solutions to that question. Let's do one more question on solving trig equations. Here it is. Now this one, we've got a sine x, a tan x, and a cos x. So as I mentioned before, you can't really solve these questions until you have either all sines or all coses or all tans. So it's not obvious what to do here, but I'll probably start by using the identity we used before, which is that tan x equals sine x over cos x. So we don't need to change the range, by the way, because these are just x's. They're not 3 x's or x plus 30 like we had before. So just leave it like it is, the range here. So let's change that tan x to sine x over cos x then. Okay, I think I would try to get rid of this fraction by multiplying everything by cos x. So make sure you multiply both sides by cos x. So that will leave you, this will just go from the denominator here to leave you with 2 sine x sine x. So that will be 2 sine squared x. Okay, we're just getting rid of this cos from the denominator. So that means we'll have 5 cos x here, and we'll have cos squared x on the right hand side. Okay, so now we multiplied everything by cos x. It's looking like we could get this all in terms of cos now, and the way to do that is to remember that sine squared is 1 minus cos squared. That comes from the very useful identity that you need to make sure you always remember this one. It comes up a lot, and that is that sine squared x plus cos squared x equals 1, or it's equivalent to 1. Should really put 3 lines there for equivalent. So that means that sine squared is 1 minus cos squared. Okay, so this sine squared down here we can replace with 1 minus cos squared x, and that's useful because now everything is in terms of cos. So let's simplify all this. That'll be 2 minus 2 cos squared x minus 5 cos x equals cos squared x. I think I'll probably get everything on the right hand side now to make cos squared positive. So if I get everything on the right hand side, I'll have 3 cos squared x plus 5 cos x minus 2 equals 0. Now this is just a quadratic. You can use your calculator to solve this. This is no different from solving something like 3y squared plus 5y minus 2. If you were to solve this on your calculator, you would end up with y equals 1/3 or y equals minus 2. Okay, so you could factorize, but I would just use the equation solver on your calculator to end up with this, either cos x equals 1/3 or cos x equals minus 2. Okay, so this bit in red you don't really need to write down. I was just showing it's the same as a quadratic equation. This line up here is just a quadratic. So now all we've got to do is solve these two equations here, starting with the one on the right. If we try to solve this, if you do inverse cos of minus 2 on your calculator, it's not going to be happy because there is no value of x that you can do cos of to make minus 2, because the cosine graph doesn't go below minus 1. So there's no solutions to this. Okay, you could check yourself by doing inverse cos of minus 2, but you know the graph doesn't go below minus 1, so no solutions to that one. So all we've got to do is solve this equation here within our range. I forgot what the range was actually. Let's go and have a look. Oh, it's 0 to 2 pi. Okay, so you've got to go from 0 to 2 pi for this question. On your calculators you can do inverse cos or shift cos of 1/3, and we're in radians for this question, so again hopefully you're still in radians from the last question. I got 1.23 on my calculator for this one. Okay, and now I would use the cos diagram. To 0, we're in radians, so that would be pi over 2. This would be pi. This would be 3 pi over 2, and this would be 2 pi here, 0 or 2 pi. Okay, so we've got 1.23. Before we use the cos diagram, if we look at this, cos x is plus 1/3. Okay, this is positive. So we need to decide where is cos positive. Well, it's positive here, it's positive here. So we're going to draw 2 lines in those quadrants. We can draw the 1.23. So 1.23 is going to be about here, 1.23. radians, and we've got to reflect that down here because cos is positive in this quadrant, so 1.23. Now we start from 0, find all the solutions within our range, 0 to 2 pi. Okay, so we've got that one already, it's down here. So let's go all the way around until we find another one. So our next value is going to be 2 pi minus 1.23. So if you do on your calculators 2 pi minus 1.23, you should get 5.05. And I don't think there's going to be any other values in our range here. 0 to 2 pi, we don't want any negative values, and we don't want anything above 2 pi. So these are the two answers. X equals 1.23 and x equals 5.05. Both are in radians.